Morning, Maylee. Morning, Lexi. You with us, Maya? Oh, wake up, Maya. All right, to start, go ahead and go to the Hampton homepage. Oh my gosh. Okay, on that Hampton homepage, if you click on VELP, at the second thing listed there, the 712 homework class checklist, 6 to 9, if you want to check on that, click on that. Okay, on the bottom, you should notice a series of tabs. You can go to your grade. So this will be updated weekly to show like what assignments are due and when they're due. So you have like a landing page for everybody's class. You don't have to keep jumping from Google Classroom to Google Classroom. So if we look at the chemistry, any questions on this thing? I think it'll help maybe organize you better. Hi. Mrs. Fuentes. What's that?
Pre-calc isn't on there.
When do you have pre-calc?
When?
Yeah.
On Wednesday.
Okay. It'll probably be on there before Wednesday. I'm not sure. Okay, the first thing listed, let's just talk about that. I think I have 3 of yours. I'm still missing 1 on the Zoom meeting notes from last time we met. So if you didn't get that turned in, maybe you just didn't like submit it. Type of reactions worksheet, all that was supposed to be filled in, and I have several of yours, I think, was just the type. And all you had to do is fill in the type. You don't have to submit it. I think I sent it back to you if you submitted it. All right, we look ahead for this week. Tomorrow, there are actually 2 things on Khan Academy that I want you to do. There's just a video on chemical reactions and then an exercise on chemical reactions. I'll put that due for Tuesday. And then whatever meeting notes we do today, make sure you submit those at least before tomorrow. Wednesday, some of you again have already submitted that. The screenshots from the 2 like games that you were supposed to do.
The don't react, like that one, it was linked on Google Classroom, right?
Yeah.
When I tried to go in it yesterday, it said it was like closed.
Really?
Yeah.
Okay. I'll check on that right now. Maybe I wonder if I didn't submit that, didn't extend the assignment. And then type of reactions worksheet. Hopefully we'll have time to talk about it. That is the rest of it. Instead of just type, we're going to try to balance those. And then Thursday, the Pogel and balancing reactions lab, that's on Explore Learning. Now that's not due until April 14th. Do you want to extend the Pogel also? You want to do that April 14th also? Give you the weekend to finish it?
Mine's already done.
Okay. Well, if you can't get it in by that particular day, you know, don't sweat it too much. If you want me to extend it, I will. Otherwise, I'll have to pass down nasty notes to your parents. Okay, let me look at that Legends of Learning thing. While I'm looking at that, if you want to open up Google Classroom, today's notes, we'll get started on that. Let's see. Oh yeah, they are closed. Okay, I'll have to look at that. Maybe I might have to just reassign it. But yeah, it looks like they're both expired. All right, everybody on that notes for today? Okay. Let's see. All right, let's start filling this thing out. So balancing chemical equations. So a chemical equation is a written representation of the process that occurs in a chemical reaction. All right, chemical equation is written with what on the left side? Those things on the left side we call left side of the arrow?
Reactants.
Reactants. And the blank of the chemical reaction on the right side?
Products.
Okay, the head of the arrow typically points towards the
Right side.
although reactions may indicate blank with reaction. This is called, they may indicate equilibrium. So a chemical reaction usually progresses in one direction, but as we build up more and more products, the reaction slows down and even starts to reverse. So sometimes the reaction can point in both ways at the same time, because as things are forming, things are breaking down again. So like and it's important in a chemical process, if we're actually trying to make a product that people are going to use, as it's being made, we need to remove the product. Otherwise, the reaction is just going to stop and not form anymore. All right, elements in an equation are denoted using symbols. Blank next to the symbols indicate the blank numbers. These are called, the big numbers outside are called coefficients. Right? And they indicate stoichiometric numbers. Stoichiometry is just the study of a reaction and pulling like the math equations out of the reaction. So those of you that you know, are great at math probably will really like stoichiometry. If math is not your favorite thing, then I'm sorry, it's just a necessary evil. All right, this tells us how many of each substance is used or reduced in the reaction. Okay, the little numbers like H2O, the 2 in water, those are called what?
Subscripts.
Subscripts. Indicate how many atoms of an element are present in each substance. An example of chemical equation may be seen in this type of reaction of methane. So what's happening to methane in that reaction? If we're reacting with oxygen, forming carbon dioxide and water, what type of reaction is it?
Combustion.
Combustion. So definition, so balancing equations, definition of a balanced equation. An equation for a chemical reaction in which the number of atoms of each element reaction and the total charge are the same for both the reactants and the products. Okay, in other words, the number and the charge are equal on both sides of the reaction. Sorry. My daughter's having like a conniption. All right, let's fill out the chart. Little plus sign, we know what that's used. It's used to separate one reactant or product from another. The arrow is used to separate the blank from the blank.
Reactants from the products.
Reactants from the products. Right. Okay, this is what I was talking about before, is as a reaction goes in both directions. This is called the equilibrium arrow. Equilibrium arrow is always this harpoon to the right and harpoon to the left, like not a full arrow. Okay, G shows a substance is what?
Gas.
It's a gas. S means it's a
Solid.
right. So we can show a gas is an up arrow because it's like escaping into the atmosphere. Solid we use as a down arrow also to show that it's like solidified. AQ means that it's dissolved in water. I gotta just mute my phone. All right, L.
Liquid.
Liquid. Good guess. Okay, this little arrow here with a triangle over the top means that there's a change in enthalpy. Enthalpy means like the amount of like energy or heat. So we can really just simplify that and say indicates that heat was applied to the reaction. Questions so far? We're good? All right, law of conservation of mass. We know we can't just create things and destroy stuff. So in all chemical reactions, law of conservation of mass must be met. Matter cannot be created nor destroyed. In a chemical reaction, atoms can only be rearranged to form new substances. Therefore, chemical reactions must be balanced. Why did I put that? All right, what is a balanced equation? A balanced chemical equation is one in which the left side of the equation has the same number of atoms and ions of each element. So if we look at that example, aluminum plus oxygen gas yields aluminum oxide. First of all, if we had to identify that type of reaction, what type of reaction is it?
Decomposition.
Well, one thing on the,
Synthesis.
yeah, synthesis. Right. When we're given that, when we look at it, the aluminum, there's only one on this side. Over here, there's two. So left side has one aluminum, right side has two aluminums. Right. Oxygen, there's two on this side and three on the other. So it's not a proper equation. So to balance the equation, the only thing you can change in the equation are never change the subscripts. You can only change the coefficients. Can't spell. Yes, I meant coefficients. All right. So pick an element. There's two aluminums over there. So what can we put here to fix the aluminums?
2.
A 2. So now our aluminums are okay. They balance. But now we have 2 oxygens here and 3 over there. Ideas?
3 and 2.
All right, if we put a 3 here and a 2 there, now we have 6 oxygen on both sides. But when we put a 2 here, what happened to our aluminums?
That's dumb.
It changes it to 4, doesn't it?
Yeah.
So to balance it, we have to put that 4 out there. So on the left side, we have 4 aluminums. How many oxygens?
6.
6. On the right side, and this is just like multiplication. This is like outside of a parenthesis. So the 2 goes to both elements. So on the right side, there's 4 aluminums. And how many oxygens?
6.
6. So it obeys the law of conservation of mass. What we started with is what we end with. You guys good so far? All right. Rules for balancing the chemical equations. Write the correct chemical formulas for all the reactants and the products. All right, we have to first have the correct base equation before we can try to balance it. All right. I write the formulas of the reactants on the what side of the arrow?
Left.
I write the formulas of the
Products.
on the
Right.
Okay, number 3, count the total number of atoms and ions in each element in the reactants and the total number of atoms and ions of each element in the products. A balanced reaction, or I guess we could say equation, oh, no, wait, that's not right. Had to read ahead. Your favorite word.
Oh.
Polyatomic ion that appears the same on both sides of the equation is counted as a single unit. So if we had a sulfate on one side and a sulfate on the other, we could just count it together. It makes it easier. And then balance the elements one at a time using coefficients. A coefficient is the small whole number that is written in front of a chemical formula. All right, when no coefficient is written, that means we have just one of them. Hey, it is best to begin with elements blank, hydrogen and oxygen. Hydrogen and oxygen are so common, we don't want to worry about them till last. So don't ever start by trying to balance your hydrogen and oxygen. You must blank attempt to balance the equation by changing the subscripts. Right? We can't change the formula for water if we need to, like, you know, we can't change H2O to H3O just to balance something. So you must never attempt to balance the equation by changing the subscripts. Okay. Check each atom or polyatomic ion, make sure the equation is balanced. And then finally, make sure that all the coefficients are in the smallest possible whole number ratios. You might have to reduce some. All right, some practice. The formation of water. Hydrogen gas reacts with oxygen gas to form water. Who can tell me the subscripts?
That one's 4.
This one's 4?
Mm-hmm. Then that's like nothing, and then it's 2.
So when I put a 4 out here in front, that gives me 8 hydrogens, though.
Oh, ha, that's funny. I meant 2. It's 2 and 2.
Why am I
You're
not?
having trouble.
I am. Okay, 2. Anything out here?
Nothing. Two.
2?
Yeah.
Okay, so that gives me 4 hydrogens. Other side has 4 hydrogens. Why is it so big now? And oxygens, I have 2 oxygens and 2 oxygens. Oh my gosh. Whatever. Oh, I give up.
You have to move the blue arrow at like the I don't know, the bar at the top. You know what I'm talking about?
No.
There's like a ruler at the top of your. No, it should just show up. It's like below the bold and like the color, like changing the color text.
Like on the toolbar, kind of.
Yeah.
Okay, what is it?
The little blue arrow, you move it over so you can go farther.
Little blue arrow.
It's like a triangle on a ruler. It's about this thick.
Really?
It's just at the top.
Like the numbers at the top that show like.
Why is it not showing up on your screen?
Okay, this is what I have.
Oh.
Is there, I don't see a triangle.
No,
Yeah,
you
it's not there.
Huh?
It's not there on yours. I don't know. Straight to what did you do?
I don't know. I've never had a triangle.
Okay, just forget it. We got it.
All right. Well, you're going to have to teach me sometime. Okay. How about the next one? Again, we don't want to start with hydrogen. Pick a different element. I mean, maybe look at chlorine.
Well, you're gonna have to do
Where's my arrow?
2 of the first thing.
Wait. Okay, 2 here.
No, you forgot an arrow. So then you have to do. Wait, no, then it's fine.
And it's fine, right?
It's
Gives me
good.
my 2 hydrogens. Gives me my 2 chlorines. And gives me my 1 zinc.
Yeah. Pretty cool.
Okay, number 3.
Oh, you need 2. And then you need 3. So then you need 3 in front of calcium.
So give me 2 aluminums, 3 calciums, and 3 sulfurs. Very good. All right. Sometimes you don't get that much help that the formula is already there. So we're going to look at writing a reaction for iron and gaseous chlorine to produce solid iron 3 chloride. So we write the unbalanced equation first. Solid iron, what's the chemical symbol for iron?
Fe.
Fe. And it's a solid, right? Plus gaseous chlorine.
Cl with G.
Cl, but chlorine is one of those diatomics. So chlorine gas is a Cl2, but yeah, with a G.
The arrow.
Right, iron 3 chloride. So iron 3 means that it has a positive 3 charge.
How'd you do that?
Command period.
Oh.
And chlorine has a -1. So what would be the formula for iron 3 chloride?
So FeCl3.
FeCl3. Oh, wow. Get both.
Are you doing
And it said it's a solid, so put the S. Right. And balanced equation. Oh, time is up. It's going to shut me off anyway. All right. So balanced equation, balance that. From last week or the week before, we talked about how many diatomics there were. So answer that question and reach out if you have any questions.
Okay.
You guys all right?
Sure.
Yes?
Yeah.
All right. Next Monday, still Easter break. So sadly, no chemistry Zoom. Try not to cry. All right. Bye, guys.
Bye.
Bye.